Hey guys, this is project 1 for ME3210 Design and Manufacturing. I'm Zach, and this is my project. This is a motor oil funnel cap. So we'll go and get right into it. The problem at hand here is simply the design of most motor oil bottles. So you'll see here that it's mainly a storage device, but you actually have to use it for more than that. Herein lies the issue. So you see here on the left, what ends up happening is that eventually you do have to get the oil out of the bottle, and a lot of people end up either waterfalling it in to a very small shaft, or having to use a funnel that you have to keep clean and separate from all other oils because you don't want different kinds of oil contaminating each other, especially when you're dealing with a 2-stroke premix or a 4-stroke small engine oil. So you really have to keep your funnels separate or keep them extremely clean, which is very, very hard to do. Hence the need for essentially a cap that functions as a funnel for the motor oil to get into the shaft without spilling, without overflowing, creating an issue, or really having to be cleaned frequently and separated. So motor oil has a very high viscosity, and so if you're going to use a funnel, you're going to have to make sure it doesn't clog, thus making sure there are large holes within the cap itself. It's a different style of cap to go on a bottle of motor oil, simply screws on with threads that meet most motor oil bottle standards because they are all very similarly manufactured. It's designed primarily for ease of use, making sure that the customer is easily able to buy it, put it on the bottle, and use it for a long period of time. It is designed for a precise distribution of oil. A lot of the time, if you're having to waterfall or pour it through a funnel, you're worried about it spilling, getting on the side of the bottle. So you really aren't focused on the distribution amount. This helps regulate the amount of oil that's being distributed into the shaft and into any internal combustion engine. It allows for an easier distribution of oil. You're avoiding it spilling, creating an issue where you're worried about it running down, once again, the side of the bottle or anything of that sort. And it eliminates the need to buy a separate funnel. A lot of the times, if you go out and are doing this on multiple different kinds of engines, then you're having to use different funnels to make sure each are clean, each are using different kinds of oil. So this eliminates the need of buying several different separate funnels or looking for a spare one because it's simply attached to the bottle and it's nice and easy to use. It's also designed for ease of manufacturing. You're working with very large tolerances and easy to make injection molds, so it doesn't really harm the manufacturing process or add anything that is extremely complex to simply making a normal motor oil bottle. The cap is also removable and thus allows for both easy cleaning and transfer to multiple different bottles. That way, it's not something that is locked to a single bottle at a time. And additionally, it seals with a small plastic torsion snap fit design for a cap to still allow for its primary function of storing oil. So getting into the design here, you see this torsion snap fit cut at the top of the shaft, along with slope siding to allow for a quicker run and allow for that high viscosity fluid that you're using through this to actually flow without clogging in total. And there are also cut threads instead of extruded threads. That way, when it goes on the outside of the bottle, you're not dealing with any excess dirt or residue. There's a proper sealage here, so it's not becoming an issue where oil is leaking through that area in the actual bottle itself and down the side of the bottle, because obviously it is a storage mechanism to start, so really trying to keep that primary function in mind while also improving the product. Going into our more of our design here, you can see the cap on top in both pictures, in both 3D and 2D form, where you're able to see the cap seal on top. Once again, it is a torsion snap fit design, so you're able to simply rotate it off when needed. It doesn't create a excess kind of wear condition. It simply allows for nice and easy sealage to avoid any spills. You see the main funnel cap body and the cut threads as well inside of the shaft itself and molded into the shaft. So the main manufacturing process behind this is simply injection molded plastic. So using that injection molding, because it is the primary source of plastic manufacturing where you are trying to get the shape necessary while still maintaining the strength of the product. The reverse hook design on the internal threads can be achieved through a core pull device. So it's just an extra design device for your injection molding machine that allows you to hook threads throughout the actual product itself, and it allows for a very easy pull of those threads. Both the cap and the seal were designed with this in mind, making sure it is an easy part to injection mold. The mold you create is also extremely easy to use. So the materials used in production are a polyurethane, terephthalate plastic is a very common plastic in most bottles, bottle caps, I should say. Motor oil bottles, same. It is a very useful plastic because it is extremely easy to mold. It is extremely strong, very lightweight, and it allows for multiple uses. It's very long lasting. It doesn't wear, and it's overall one of the better plastics for this consumer application. And then also using a proper injection mold from your injection molding machine, creating that injection mold and going from there. The advantages of this product are that it eliminates the customer need for a funnel, even with the additional cost of creating extra molds versus a normal cap. It also comes out as a net benefit to the consumer because any small, very small price raise that comes from this also is offset by not having to buy an extra funnel, which is going to cost vastly more. More precise method for pouring, so it allows the consumer to get an actual proper distribution of the oil without having to worry very much about it also being messy. It is extremely easy to clean, easily transferable between multiple bottles, and designed primarily, once again, for ease of use and ease of manufacturing. The disadvantages: it is a slower distribution than you would see through a normal funnel because the hole is smaller in the top of the cap than it would be normally outside of just the normal threads that exist on current motor oil bottles. But that also is an advantage in terms of being more precise. It is a more complex manufacturing process. You are creating more molds and needing to properly distribute those among the manufacturing process. The seal is also not as tight. Although the snap fit design has its advantages, it is not as tight as a threaded cap on the top, but it is extremely easy to use. And then different size bottles require different size caps. So if you're dealing with a 4-stroke small engine oil bottle versus a normal automotive bottle, you do have to buy a different sized cap, and thus more molds have to be created to distribute those among different designs. So these are the resources utilized for this project. And just a disclaimer, this is for educational purposes only and should not be treated as a real product.